In 2008, at the same time, two of Elon Musk's projects were close to collapse. One was struggling to launch an object beyond Earth's atmosphere. The other was attempting to build a car in a way the automotive industry had never done before. To understand how events reached this point, it is necessary to go back several years, to a time when everything was still far from crisis. In 2002, Elon Musk sold PayPal to eBay. From the transaction, he received more than $100 million. At that time, Musk was not involved in the day-to-day operation of any other major technology company. He spent his time studying areas of interest, including space and energy. As he began examining aerospace, Musk focused on the cost of rocket launches. Sending 1 kilogram of payload into low Earth orbit typically cost around $20,000. This figure had remained largely unchanged for many years and was accepted by the industry as standard. Musk analyzed the cost structure of a rocket. Most of the materials consisted of common metals, engines, and mechanical components manufactured through standard industrial processes. However, after each launch, the entire rocket was either destroyed or left in space, requiring every flight to absorb the full cost of production. Based on this observation, Musk concluded that high costs were not driven by materials, but by the industry's acceptance of single-use rockets. He began exploring the possibility of purchasing surplus rockets to reduce upfront expenses. In 2002, Musk traveled to Russia to negotiate the purchase of refurbished ballistic missiles. The negotiations failed. After returning to the United States, he concluded that buying rockets did not address the core problem, and that the only way to reduce costs sustainably was to design and build rockets from the ground up. After returning from Russia, Elon Musk continued analyzing the cost of rocket launches. He focused on a basic fact. In most space programs, rockets were used only once. After completing their missions, most of the vehicle's structure was destroyed or left in space. This meant that each launch had to absorb the full cost of design and manufacturing. Although the materials themselves were not scarce, total costs remained high because there was no reuse. The industry had accepted this model for decades, partly due to technical risk and partly because earlier programs were funded primarily through government budgets. Musk identified this as the main reason launch costs had not declined over time. He assumed that if rockets could be recovered and reused, the average cost per launch would fall significantly. Based on this assumption, he decided to form a new company to test this approach. In 2002, Space Exploration Technologies, later known as SpaceX, was formally established. The company's initial objective was not to compete directly with major contractors, but to build a small, simple rocket at a lower cost than existing options. SpaceX chose to design and manufacture most components in-house rather than relying on traditional suppliers. This approach provided greater cost control, but it also placed the full technical risk on the company itself. At that time, SpaceX had no major contracts, no launch record, and was not regarded by the industry as a serious partner. However, the company had clearly defined the problem it intended to address. Spaceflight remained expensive not because of physics, but because of how rockets had long been used. From 2006 to 2008, SpaceX entered its first testing phase with the Falcon 9 rocket. This was a small launch vehicle designed to demonstrate that a private company could independently develop and launch a rocket into orbit at a lower cost. The first launch took place in March 2006. The rocket lifted off from Omelek Island in the Marshall Islands. Seconds after leaving the launch pad, the engine experienced a failure, and the vehicle fell into the ocean. The mission ended without achieving any technical objectives. The second launch occurred in 2007. Falcon 9 flew longer than the first attempt, but a fault in the control system caused the rocket to lose stability and fail to reach orbit. SpaceX continued to analyze the data and modify the design. The third attempt, in 2008, came very close to reaching orbit. However, A minor collision between rocket stages during stage separation caused the engine to shut down early. 3 launches resulted in 3 failures. Each attempt cost tens of millions of dollars that could not be recovered. By this point, SpaceX was nearly out of cash. The company no longer had sufficient resources to continue long-term testing. Staff reductions followed. External observers viewed this as a sign that SpaceX was approaching its end. The 4th launch was prepared under the most severe financial constraints. Another failure would have left SpaceX unable to conduct any further flights. In September 2008, Falcon 1 launched for the 4th time and successfully reached orbit. Shortly afterward, SpaceX received a contract from NASA, providing enough funding for the company to survive and move into the next phase. While SpaceX was conducting its early launch tests, Elon Musk was simultaneously becoming more deeply involved in another company. That company was Tesla Motors, founded in 2003 with the goal of producing commercial electric vehicles. Musk was not a founder, but he became the largest investor and later assumed an executive role. At that time, the automotive industry had been stable for decades. Major manufacturers controlled supply chains, engineering platforms, and distribution networks. Electric vehicles existed mainly as experimental projects, with low production volumes and limited use. Most automakers did not treat them as a serious business direction. Tesla chose a different path. Instead of starting with a low-cost car, the company developed an electric sports car, later called the Roadster. The objective was to demonstrate that an electric vehicle could deliver high performance and be attractive enough for customers to pay for it. The process quickly encountered difficulties. Production costs exceeded initial estimates. The battery system proved more complex than expected. Dependence on external chassis and components caused repeated delays. Fundraising rounds became increasingly strained as the company had not yet generated profit. By 2008, Tesla faced the risk of being unable to continue operations. The company was short on cash while still failing to complete a product ready for delivery on schedule. Musk had to inject additional personal funds to keep operations running in the short term. Entering the automotive industry did not provide Tesla with any immediate advantage. Instead, it placed the company in a highly competitive environment, where small mistakes in manufacturing and finance could quickly push a young firm toward closure. After their initial breakthroughs, SpaceX and Tesla faced a similar challenge. The issue was no longer proving an idea, but repeating it at scale. This was the stage at which many technology companies failed, not due to a lack of innovation, but because they could not operate reliably. For SpaceX, NASA contracts required clear launch schedules and high reliability. A single successful launch was not sufficient. The company had to demonstrate that it could launch repeatedly, with controlled costs. At this stage, each technical error was no longer an experimental setback, but a potential cause for contract loss. Tesla entered an even more difficult phase as it prepared for mass production of its next vehicle models. Large-scale automotive manufacturing required tight coordination between design, supply chains, and factories. Minor issues in assembly could halt entire production lines. Costs rose faster than revenue, while pressure to deliver vehicles on schedule increased. Both companies chose to increase internal control over manufacturing. SpaceX expanded its in-house production capabilities. Tesla invested heavily in factories and automation systems. These decisions improved long-term control, but placed significant short-term strain on finances. By the end of the 2000s, Musk had to allocate personal resources to keep both companies operating. There was little room for error. Mass production became the clear boundary between continued survival and withdrawal from the market. By the late 2000s, SpaceX and Tesla could not yet be considered successful by conventional standards. Both had narrowly avoided bankruptcy, but continued to face increasingly strict operational demands. During this period, a common pattern became clear. Both companies were built on the same underlying logic. Cost reduction was pursued not by reducing ambition, but by changing structure. SpaceX focused on reusability and producing most components in-house. Tesla focused on batteries, software, and deep control over its production chain. These choices made the early phase more difficult, but created a foundation for improvement over time. Rather than optimizing individual components in isolation, both companies aimed to control the entire system. This allowed faster design adjustments, quicker learning from errors, and gradual cost reductions with each iteration. Improvements did not occur through a single major breakthrough, but accumulated through repeated testing and incremental changes. SpaceX began launching rockets more frequently and recovering booster stages. Tesla gradually expanded production and reduced battery costs across successive vehicle generations. There was no specific moment that marked a transformation, only a trend that became clearer over time. In hindsight, the decisive factor was not the final products, but how these companies were built to operate over the long term. They were not designed to avoid failure, but to continue operating after failure. That capability allowed both SpaceX and Tesla to move through a phase in which many other companies were forced to stop.